Yep, we're going out of order. We're going to do part of section 6, and we're going to go into section 4, and then we're going to come back and finish up section 6. It makes sense in our all the math teacher said, so that's the way we're going to do it. This is about compound inequalities, so it has two sections to it, two pieces. So they're called compound statements. They sometimes are real explicit about having an and, the word and in them, or the word or in them. Sometimes they're not. Sometimes they're a little bit sneaky. If you have an and, it is called a conjunction or an intersection. I've forgotten. I believe your book calls them intersections. When I was in school, they were called conjunctions. And when you're looking at those problems, basically you're looking for what is the same in their solutions. When you have ors in the problem, or when you're trying to figure out does it actually represent an or, it's a disjunction. That is the kind of old word for it. Or basically it's a union. And I believe that is what your textbook, or what it's more commonly referred to as. And what that is what can we put together? Or actually, not what can we put together. It means you are putting together your solutions. So it doesn't really matter what is in common. It is just you're taking this solution of this piece and this solution of this piece, and you're just putting everything together. So you're taking all of the solutions and putting them together. So it doesn't have to just be just what is in common. That is the intersection. The intersection is really specific and nitpicky. So we're going to look at these two things. The top is an intersection. The bottom is a union. So let's look at what happens there. When you have an intersection, the solution for A is everything below 5, then everything above -1. Now we have to take just the pieces that are in common. So that means the actual solution is only the numbers between -1 and 5. You cannot take what goes beyond the -1 and what goes beyond the 5, because those would not be in common. It has to be above -1 and at the same time below 5. It can't go beyond those, because then it would not be true. Now for your union, it can be either less than -2, or it can be greater than 2. So what numbers satisfy that? Well, for the solutions of A, numbers are less than -2. You've got numbers that are greater than 2. And so these are the solutions to that union. You just stick them together. There you go. So here's a problem. We don't know what that is. It's sneaky. It's actually an and. And the way you understand this is if you have an expression that is sandwiched between two inequality symbols, and it is a smaller number less than a larger number, if you notice that, so you've got the smaller number and both of these are less than the larger number, then you're going to have a intersection. So what you have is you're going to break these up into two pieces. So basically you can ignore the upper number. You've got your intersection, or your expression with the lower number. So that's this piece. That's why we've got the circle here. And then you can ignore the lower number, and you've got your expression taken with your upper piece. And so that's how they wrote these two pieces. So here's the lower piece. So the circle and the arrow. There's your lower piece. And then there's your upper piece. Circle and the arrow. And that's how you write your two pieces. And then you solve. And then there's your graph. So greater than -4, less than 1. Intersections have to go between those two. Here's a disjunction, and they are explicit. They tend to always be explicit. I don't think your book has tried to be tricky at all. My high school, it was in my books. Okay, so you've got these two pieces. So how will those go? Well, pretty simple. We're going to solve here, and then we're going to solve here. And then we solve, just like an equation. Just remember those that rule that if we divide by a negative, like we did here, the sign flipped. And then you graph. So what was below -1? What was above 2? And that's it for compound solutions. or inequalities rather.